All right, section 2.1. Trigonometric functions of acute angles. So what is an acute angle again? Less than 90 degrees, yeah. All right, so let's start off with drawing a right triangle in the standard position. Let's put the terminal side in quadrant 1 because quadrant 1 is 0 to 90, right? So we want an acute angle. I'll draw that. The x-axis, the y-axis, relation. And this right here, let's call it theta. Let's say make a triangle out of this, right triangle. All right, so triangle ABC has a value of theta in here equal to who knows what number. All right, so we know that this right here, dash it in blue, that's our x units long, right? So whatever that may be. And then from here, so from point C up to point B, that's y units long. Then over here, that was R, right? All right, so in relation to theta, x right here is one of the rays that forms that angle, right, between x and r for theta. And that is adjacent to theta. So it's like touching the angle, right? It's part of it, part of the rays. When I look at side y in reference to theta, y is opposite of theta. And r is still like if I said the origin to a point, say B, that's the distance, right? But now we can just say this is the hypotenuse. So now we're looking at the sides of the triangle. Instead of x, y, and r's now, we can say in terms of opposites, adjacents, and hypotenuse. So if I look at the sine of theta is equal to, we knew before, it was y over r, right? So y is opposite. R is hypotenuse. Cosine of theta was x over r, which x is adjacent to theta. R is hypotenuse. Next we have tangent, which was y over x, opposite over adjacent. You may have heard this mnemonic before. Take the first letters of all of these. S, O, H, C, A, H, T, O, A. Sakatoa. May have heard that, may have not. Okay. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay. So that's another way when we're especially going to be dealing with just triangles, is in relation to what those angles are. I can find the opposites, I can find those adjacents, and I can figure out all trig functions from there. So if you know these basic three trig functions, you now know their reciprocals. The reciprocals of sine is cosecant, which would be hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over hypotenuse. I'm sorry, adjacent over the opposite. All right, so this is probably the most common one most teachers teach to remember: sine, cosine, and tangent, SOHCAHTOA. I've learned it a different way. Just knowing that it's sine, cosine, then tangent is one way. I always thought, still use a different one. I'll tell you mine that I use. Oscar has a heap of apples. Oscar has a heap of apples right here. I like this one. This one always stuck. I never forgot it. I still think about it even as I teach this. Oprah, I know Oprah Winfrey. Oprah has a huge old a. Yes. Never forget it. Or if you know anybody's name that starts with an O, you put that one in there, okay? Whoever it is. Okay, so you can make up any kind of things just to help you remember things, right? So if they're funny, most people will remember them, right? Another one using SOHCAHTOA, but not just saying it that way. The mnemonic, I've heard some old hippie caught another hippie tripping on acid. That's about the basic ones that I've heard. I know there's several out there. Look them up on YouTube or something. You'll probably find some comedians coming up with some of this stuff. Search math comedians, right? All right, so let's just do an example. Given a triangle, right triangle. We're only dealing with right triangles so far. That's supposed to be a triangle. That's terrible, huh? Let's fix that. So triangle ABC. I have two legs. I can figure out the hypotenuse, right? Let's figure out what that may be. Use Pythagorean theorem. That's just 7 squared plus 24 squared is equal to hypotenuse squared, right? C squared, if you want to call it that way. All right, so 7 squared plus 24 squared, 7 squared, that's 49. Plus 24 squared, oops. Try this again. 49 plus 24 squared. That's 625. Yeah, that's a nice number because the square root of 625 is technically plus or minus 25, right? But we're looking at a triangle. Triangles don't have negative sides, right? So we just got to throw away the negative. And so our hypotenuse is 25 there. So let's figure out our trig function values for the angle, let's say A. Sine of A. Opposite of A is 7 over the hypotenuse 25. cosine of A is adjacent to A is 24 over hypotenuse 25. Tangent of A, opposite over adjacent, or sine divided by cosine, right? We know that just now from that previous section. I can say 7/25 divided by 24/25 is 7/24. And they're reciprocals. Cosecant of A is flip 7/25, 25/7. Secant of A will be 25/24. And cotangent of A is 24/7. We don't know what A and B are, right? We don't have those measures. We don't need those measures, but we can figure those out later on. We'll get to that. We'll figure out how to find what angle values are all in the triangles. All right, let's look at B. Sine of B. All right. Now, opposite of B is 24, which was adjacent to A, right? So now they're trying to change names in a sense. It's all relative to what angle you're looking for. So sine of B, opposite 24 over hypotenuse 25. All right. Y'all probably could do the rest, right? Go ahead. All right, so our cosine is going to be adjacent to B is 7, hypotenuse 25, tangent opposite is 24, adjacent is 7, cosecant, now flip all those are pretty simple. There you go. Now take note the relationships between sine, cosine, tangents for A and for B, for each one of them. Notice the sine of A is 7/25, but it's also like the cosine of B. The sine of B is the same as the cosine of A. The cotangent of A is equal to the tangent of B. So see the word co, the prefix in there? Those are called cofunctions. Okay, so A and B, if you look back at the triangle, we've got C right here, has to be 90 degrees, right? So how much is this total of A and B? Sum of all three angles in a triangle is always 180, right? So A plus B, we don't know specifically what they are, but we know their total is 90. Right? So that makes 180 as your sum for all three angles. So A and B are complementary if they add up to 90, right? So let's write that down. A and B are complementary angles. So if I look at something like sine of A, we know that this was equal to the cosine of B, right? Those are cofunctions right there. And then A and B must total 90, right? So we do this with all the other trig functions too. I can say that let's do cosecant of A has to be equal to the secant of B, right? Same thing. These are co-functions. And A and B totals 90. And then the other one we could do is tangent and cotangent, right? So I could say tangent of, say, A has to be equal to the cotangent of B. So these are your co-function identities, they call them. So that's what I was telling you. Now we're going to get to the next section and start looking at these special angles. If I look at all these trig function values of, say, 30 degrees, I automatically now know all the trig function values of 60 degrees. Right? So you still want to commit a lot of these to memory, but you know what? You can get yourself out the box to get to the other ones if you need. All right, so if I say right in terms of its co-function, fill in the blank. All right, cosine of 52 degrees would be the sine of 38 degrees. Tangent 71 is the cotangent of 19. And secant is the of 24 is the cosecant of what, 66. All right, so let's look at those special angles. Let's look at the 30 and the 60 degree angles. If I draw an equilateral triangle, so if I draw any equilateral triangle, the interior angles each measures 60 degrees, right? Sum has to be 180. Now from here, we talked about similar triangles last time, right? We could scale these up or down, make them big, make them really small, whatever. But the triangle angles still remain always the same, right? So if I pick any number for this side for an equilateral triangle now, it's always going to be that same number for all the sides, right? So you pick any number you want. How about just a 2? I don't know. You pick whatever you wish. But we'll keep it with small numbers, make it easier. All right. I said we're only dealing with right triangles, right? That's how we get our trig function values, is from right triangles, not from equilateral triangles, right? But can I make this a right triangle? Just cut it in half, right? So if I split this in half, I create 2 right triangles. All right, so over here, so I'd have this triangle and one that looks exactly the same, just rotated around, right? Just want to think of it that way. All right, so looking at this picture, and let's say this is triangle 1 right here on the left side. This is 60 degrees, right? Said earlier, now I've got 60 degrees, 90 degrees is 150 degrees, therefore there's only 30 degrees left over, right? So these two, if they were A and B perhaps, that's a total 90. This side is 2. This side right here, look, it's split it in half, right? So now this is just 1. So this is one of the legs of the right triangle. We don't know, right? So let's just put X. Actually, let's call that as, that's good. We can leave it as X. I can use Pythagorean theorem to figure this out, right? So I can say x squared plus y squared is r squared, or a squared plus b squared equals c squared, whatever. So x squared plus the 1 squared is 2 squared. All right, so that's 4, that's 1. 1 from 4 is 3. And I take the square root of both sides. Technically, it's positive or negative square root of 3, but we're dealing with a triangle again, so we're just going to use the positive square root of 3. All right, so now I have all sides of the right triangle. I don't need to worry about the second one, right? Same picture. Let's figure out sines and cosines and tangents and all trig function values of, let's look at 30 degrees first. In relation to opposites, adjacents, and hypotenuses. Sine of 30 is opposite over hypotenuse, right? Our opposite of 30 degrees is 1. Hypotenuse is 2, 1/2. Cosine of 30, adjacent over hypotenuse. Adjacent to 30 is the square root of 3. Hypotenuse is 2. Tangent of 30, opposite over adjacent. Opposite was 1, adjacent square root of 3, and if we rationalize that, that gives us square root of 3 over 3. All right, we can do the reciprocals too real quick. Cosecant of 30 degrees. Flip 1/2, you get a 2. Sine 30 degrees. Flip 2. Flip square root of 3 over 2. Gives you 2 over the square root of 3. Rationalizes 2 square roots of 3 over 3. And cotangent of 30 degrees. Flipping from right here, 1 over the square root of 3, which is square root of 3. All right, so we got all our 30-degree ones. Our 60-degree ones are pretty easy to come up with now. You can either use cofunctions, or you can do the same thing we just did, opposite, adjacent, lines. So sine of 60 is the same thing as cosine of 30, square root of 3 over 2. Cosine of 60 is the same as sine of 30, 1/2. Tangent of 60 is the same as the cotangent of 30, square root of 3. And now the reciprocals are easy to come up with too. Cosecant of 60 degrees is the same as the secant. I put sine right here. I see a mistake. Let me erase that, fix this. That's secant. All right, so cosecant of 60 is the same as the secant of 30. That's the 2 square roots of 3 over 3. Secant of 60 is the same as the cosecant of 30. 2. And cotangent of 60 degrees is the tangent of 30 degrees, square root of 3 over 3. And again, you can check and make sure this right here, that is on still our hypotenuse, 60 degrees, opposite over 3. Cosine of 60 is adjacent over our hypotenuse. Adjacent to 60 is 1, hypotenuse. So if you know 30, you know 60. And notice everything is either 1/2 or square roots of 3 over 2. Or square root of 3 over 3, or something involving square roots of 3s, right? A lot of times. So get familiar with the calculator too. You know what those decimals are a little bit, trying to recognize them. Obviously, 1/2 is 0.5, that one's easy. And then square root of 3 over 2, that's about 0.866 something something. So if you see that decimal in the calculator, you're like, I know what its exact value is. That's square root of 3 over 2. All right, the other special acute angle is the 45-degree one. All right, so again, we can draw a right triangle for this one. So if that is 90 degrees, this one's 45 degrees. What's the other angle in there? Also 45. Remember, these two have to be complementary to each other in a right triangle. All right, what kind of triangle we have now? It's an isosceles. So with an isosceles triangle, if this is 45, this measurement over here is something, but if that's 45, this measurement is also that same something, right? You pick any numbers you want, right? As long as you pick these two legs to be the same length. How about we just pick, it doesn't matter, whatever you want. How about make it big, I don't care, 12. The easiest one would be 1, right? That's the easiest thing to work with. But you can just see any size triangle, all your trig functions of those angles are still always going to be the same thing. So Pythagorean theorem would say that's 12 squared plus 12 squared is equal to r squared or hypotenuse squared. Let's just say I call it c squared. It doesn't. That's 144 and 144, which is 288. Which that was 2 times 144, right? Take square root of both sides. All right, square root of 2, can't do nothing with that, but the square root of 144 is 12. So that's 12 square roots of 2, which is equal to our c. Now we just build our trig functions. Sine of 45 degrees. You can look at either one of them, right? It doesn't matter. Let's go from this one. Opposite is 12 over hypotenuse, 12 square roots of 2. 12's cancel, leaving 1 over the square root of 2. And if we rationalize it, we get a square root of 2 over 2. Cosine of 45 degrees is now adjacent, which is 12. Same thing as it was for opposite over hypotenuse. Like we get the same thing. Square root of 2 over 2. So sine of 45 degrees and cosine of 45 degrees give you the same exact wave function value. Square root of 2 over 2. And if you put that in the calculator too, you'll see that's about 0.707 something. Recognize that number. The tangent is pretty simple. Opposite over adjacent, that's 12 over 12. 1. The tangent of 45 is always 1. And let's continue doing the reciprocals. Cosecant of 45 degrees. We flip sine of 45 degrees. You can flip it right here. That's just a square root of 2. Secant of 45 degrees, same thing, flipping cosine of 45 gives you the square root of 2 as well. And lastly, cotangent of 45, flipping 1 gives you 1. Some of you may want to memorize this in a table format. That's perfectly fine. So we'll just do this real quick. So we start off with 30 degrees. And that's 1/2 square root of 3 over 2. This is square root of 3 over 3. That is 2. That's 2 square roots of 3 over 3. And this is the square root of 3. Again, now if you know those, 60 degrees is pretty simple. Square root of 3 over 2. This is this one, 1/2. This is this one, square root of 3. This is this one, 2 square roots of 3. That looks better. 2 square roots of 3 over 3. Secant is that one, 2. And cotangent, square root of 3 over 3. So like I said, you know one, you know the others. As long as you know what cofunctions are, you can just kind of flip them around in there. And then 45 is the easy ones we just did. Square root of 2 over 2, square root of 2 over 2, 1. This is the square root of 2, square root of 2, and a 1.